Okay, so am I audible to you? Just confirm me whether you can hear me. Yeah. So today we go for our next lecture, that is the third lecture on production engineering. And the purpose of these videos is for your upcoming exam, that is BHEL and HPCL exam, in which a lot of questions come from production engineering. So today the topic which I am taking in third lecture, first lecture was about metal casting, and the second lecture was about welding. And today my third lecture is about unconventional machining, non-traditional machining processes. It is one of the very important topic, and in my opinion, in these three lectures, welding, casting, and non-traditional machining, I think a very good number of questions can be asked, and they are data oriented questions, also very basic questions. So as I tell you in all my lectures, all my classes, that the exam BHEL and HPCL exam, the kind of exam pattern or questions asked will be different from kind of questions which you can get in GATE and all. So prepare well for these exams. Straight questions come, data information loaded questions come. So let us start with our lecture, and this is related to non-traditional machining. So before I go for first question, I tell you non-traditional machinings are different from conventional machining in many aspects. So non-traditional machinings are no doubt costly machining. They are the special purpose kind of machining processes, and these machinings are basically used where the conventional machining processes cannot be used. So some materials are not machinable. We know that in traditional machining processes, the hardness of the tool should be more than that of workpiece. But in non-traditional, what we find is there are different mode of energy. I mean, different modes of energy are used. Not only plastic deformation mode only, which is used in traditional machining. We use different mode of energy, and that is used to machine even those materials which are difficult to machine materials like ceramics, like brittle materials. So we can categorize this all non-traditional machining processes into form of energy, that can be given in particular machining process. So mechanical energy, thermal energy, chemical, electrochemical energy, electrical energy. So if you see in electric discharge machining or wire cut EDM, the electric machining energy is the energy which we use. Similarly, chemical machining process, electrochemical machining process, electrochemical machining processes may you are making use of chemical energy. Then there is a thermal, electron beam, laser beam, plasma. Then in the mechanical process, where again, like plastic deformation or erosion is one of the mode of material removal. So this categorization is important. You should know what this categorization is, how we divide the non-traditional machining processes, in how many categories do we divide that. So this is one of the important slides. You should know how we divide this, and this slide is even more important because this slide is telling you about what kind of micro machining. So this non-traditional machining processes are micro machining processes, they are called. Why? Because the material removal is not that high as we see in the conventional machining process. In the conventional machining processes like turning, milling, shaper machine, you must have seen that the material removal rate is very high. In the turning operation, you get something like chips, you get the in the form of chips and all. But in non-traditional machining processes, material removal rate is not that high, and these machining processes are used for very micro operation, micro machining operation. That means material removal is very less, and the basically the kind of machining which is done, cutting which is done, is of very small size. Think of laser beam machining, think of wire cut EDM. So very small material is removed, not the kind of material removal rate which we see in the traditional machining processes. Yes, industrial engineering ka Subir, I'm planning next classes are going to be industrial engineering. So this my series till your exam is going to be production engineering and industrial engineering only. So that is how we are going to pull it forward. Okay, so ultrasonic machining is best, and I want these classes to be more interactive. I want that you should be interactive in the class. The question is given and you should keep on answering simultaneously, so that you understand how these questions can be answered. Ultrasonic machining is best suited for what? So ultrasonic machining is best suitable for what? You are saying B, somebody is saying A. Answer for this is the brittle material. So abrasive jet machining and ultrasonic machining. Remember these two things. Somebody asks you how do you cut the glass? The answer for that is you cut the glass through abrasive jet machining and ultrasonic machining. These two are the machining operation which we do for basically cutting the very brittle material. Glass is a brittle material, and ultrasonic machining and abrasive jet machining, these are the two machining operations which are used to make the holes in glass plate. I mean, glass is a brittle material. So in ultrasonic machining, there is a vibrating tool which vibrates at this frequency. Many exams may this frequency is also asked. What is the frequency at which the tool is vibrating in ultrasonic machining? 20,000, 30,000 kilohertz. And amplitude is in micron, or you can say 10 micron or 0.01 millimeter. So remember what is the depth and what is the kind of vibration frequency. So you need to remember these two things are very important, like what is the frequency coming for this and what is the amplitude coming. These two things are important. And slurry, abrasive slurry is made up of ceramic material. So boron carbide mixed with water, that is a slurry is supplied. So that is basically supplied under pressure because the gap is very less, and what we get is the same kind of shape you get as that of the tool. So cavity is produced similar to the shape of the tool. That is how it is done. And it is material need not to be conductive, so it is non-conductive. Glass is non-conductive. So this is how it is used. So a lot of information in this small passage. So remember this information: ultrasonic machining, abrasive jet machining for cutting the glass. Remember that it is a brittle material. So also ultrasonic machining has certain applications, and that is for glass, carbide, ceramics, hard and brittle work material. Also for sometime other metals like stainless steel, titanium also you can use it. And holes can be produced, different shapes can be produced, and this can be blind hole can also be produced. Coining operation is one of the example of this. So also remember what are the applications of non-traditional machining. So application also you should know. So as you can see, this is the horn, this is a concentrator, piezoelectric transducer, high frequency power supplied, oscillator is there. So sometime he will ask you about what kind of slurry, what is the slurry, what kind of abrasive particles do you use, why do you supply this slurry at high pressure, what is required. Abrasive jet machining, water jet machining, so these are other examples of that. So small difference between these couple of non-traditional machining processes. So what is horn? You should know that particular thing also. Next question is, which of the following process has highest material removal rate? Very important question. Any guess you want to give? Which of the following processes has highest material removal rate? What is your guess for that? What is the highest material removal rate for this? Right? So which of the following processes has highest material removal rate? Any guess for that? So he has given you a couple of options here. Just guess which one has highest material removal rate. And the answer here is this. Please remember the sequence of increasing order. Maximum is electrochemical machining and minimum is laser beam machining. So electrochemical machining, EDM, ultrasonic machining, electron beam machining, laser beam machining. So remember, this is a very important sequence, and you should know what is the sequence. Electrochemical machining में maximum material removal rate you can acquire. ये electrochemical machining जो है electroplating का opposite है. You must be knowing there is something which is called electroplating. उसका reverse is electrochemical machining. Material removal rate is maximum in that. So pump use होता है इसके लिए. You are using the pump, and also sometime he will ask you the question that what is cathode, tool is used as anode or it is used as cathode. So that particular thing also you should know, whether tool is used as anode or it is used as cathode. And what do you mean by anode and cathode? So you see, workpiece is a positive, tool is negative. So negative is cathode, cathode is negative and workpiece is positive. So remember, electrochemical machining mein workpiece is positive, which is used as anode, and tool is negative, which is used as cathode. And electrolyte is pumped at very high pressure in this, and this metal hydroxide is formed. There is a mechanism here that also you should know. Okay, let's go for next question. Vibration frequency used for ultrasonic machining. I just gave you the answer for this. Can you tell me what is the frequency of ultrasonic machining? What is the vibration frequency used in ultrasonic machining? Any idea about that? What is the frequency of ultrasonic machining? Yes, the answer for that is 20,000 hertz or 20 kilohertz is the frequency of vibration, right? And this is used if the hardness of the material is hard and brittle. So ultrasonic machining will be very effective if material is hard and brittle. Ductile material ke upar it is not very very effective because the abrasive will get impinged in the ductile material. So abrasive slurry is used in ultrasonic machining, and ultrasonic machining normally is used when the hardness of the workpiece is more than 40 Rockwell number, right? So that is how it is used. It can be used for metallic, non-metallic, conductive, non-conductive, composite, glasses, ceramics. All these things can be done. So piezoelectric material is used, and ultrasonic tool is attached. The horn will basically enhance the amplitude, and slurry will be supplied from the pump separately. That is how it is done. And the shape of the tool, shape of the workpiece is similar shape is obtained. This is how this information you should know. Okay, so in abrasive jet machining, metal removal rate takes place due to which mechanism? So, what is the mechanism of material removal in abrasive jet machining? Any idea about that? So, what is the mechanism of material removal in abrasive jet machining? So, abrasive jet machining, metal removal is because of which mechanism? Okay, so you are saying it is erosion. Erosion means plastic deformation, cutting. So वो कट लग जाता है. So when you supply the abrasive particle at very high velocity, note down the velocity also, 150 to 300 meter per second. Sometime he will ask you, that is where exams like BHEL, HPCL are different from GATE exam. So very high speed पे abrasive particle, कौन सा abrasive particle use होता है, that question also is asked. So high speed पे abrasive particle को वो फेंकेगा, and that nozzle tip distance is also one parameter. So nozzle का tip and workpiece के बीच का gap is important parameter, because the abrasive is going to accelerate within that gap. It is going to accelerate within that gap, and the tip workpiece gap is one of the parameter which decides material removal rate also. So material removal rate depends upon tip workpiece gap also. So nozzle tip distance or stand off distance, this is also called stand off distance. So note down these values also, and nozzle tip ka size also you should know. So what is the stand off distance? What is called stand off distance? Nozzle tip distance from the workpiece is called stand off distance. It should be 0.3 to 20 millimeter. So I'm sure you people are noting down these things. And the nozzle tip is made up of tungsten carbide or gem, GEM. So it is made up of tungsten carbide or gem. That information also you should be knowing. And the mechanism is nothing but erosion is the mechanism through which this is removed. So it is removed through the erosion process. This is how it is done. So gas is air, and in air there are abrasive particles. So aluminum oxide, silicon carbide, they are the abrasive particles. Okay, machining process which needs vacuum for its operation. In which of the machining processes do you need vacuum? Yes, any guess for this? Which machining process requires the vacuum for its operation? Any idea for this? Which machining process requires vacuum? ओके, इलेक्ट्रॉन के लिए वैक्यूम चाहिए होता है. इलेक्ट्रॉन के लिए इलेक्ट्रॉन बीम मशीनिंग में वैक्यूम चाहिए होता है. सो रिमेंबर, इन द इलेक्ट्रॉन बीम मशीनिंग देयर इज अ डिफ्लेक्शन कॉइल आल्सो. देयर इज अ डिफ्लेक्शन कॉइल आल्सो. सो बहुत एक contour shape of cutting can be obtained, because electron are charged particles, and when these charged particles pass through magnetic field, we can get a very different kind of contours or shapes can be obtained, and that is the reason we supply it through this particular deflection coils, electromagnetic coils. Vacuum chamber is created in this. And why that is done? Because electrons should not collide with air molecules. So it is best suitable for small parts. Hazardous X-rays are formed, and in this particular case, so you need to be very very protected for this particular machining process, electron beam machining. So in this diagram, whatever information is provided, that is worth noting. You should note down this entire information which I am providing you. Okay, what is the material of the tool in EDM? Any idea? Electric discharge machining mein what should be the tool material used? Okay, is it diamond, copper, tungsten carbide, high speed steel? What is the material of the tool? Any idea? Any guess you want to do? Okay, so Tarun is saying high speed steel is the material. Okay, so you people are saying copper is the material. Any other guess? So what is the material of the tool in EDM? So yes, these are the different tool. Electrodes can be used in electric discharge machining. It can be copper, because you need to be conductive. It can be graphite. It can be brass. It can be electrolytic oxygen free copper. So that means copper. So note down these materials. They are the tool materials. So what is required in tool of electric discharge machining? You need to have a tool which is actually a very good conductive material. It should be conductive material. Actually, that is the requirement. It should be conductive material. So electrode material should have high density for less tool wear and less dimensional loss. So density should be good. High melting point should also be there. Easy manufacturability should also be there. Cost should be cheap. And from that perspective, graphite and copper plus sterilium, some alloying element, can be the best suitable material for electric discharge machining. So this can be very good material for that. So note down these important points. And in the electric discharge machining only, you have servo control. Now what is the meaning of servo control? Many times exam mein question is asked from servo control also. So we need servo control for electric discharge machining process also. That means servo control is giving you feedback about the gap between the electrode and workpiece. And if that gap changes, then obviously tool feed is maintained. So servo control decides the tool feed, and we want to maintain constant gap because the spark is produced as per the gap, and hence servo control is used. So electric discharge machining mein, what is the tool? What is the criteria of the tool? What is the mode of material removal? What is the type of energy requirement? And what is the mechanism of providing the discharge? So that is servo control is used in this particular case. That is very, very important. And dielectric fluid is kerosene. So remember that what dielectric you are using is kerosene, and the tool is normally copper based tool, and the servo control is provided to maintain the constant gap. So as I'm telling you, these slides are very, very important for your exam, and I'm very sure some question is going to pop up from here. Okay, so in electrochemical machining, how do you get the material removal? Electrochemical machining mein the metal is removed by which of the following? The material is removed by what? Electrochemical machining, metal is removed by what? Okay, so metal in electrochemical machining is through dissolution of the metal work. It is a electrochemical machining is electrochemical form of energy, and it is opposite to electroplating. So material removal rate takes place because of atomic dissolution. So answer for this is dissolution. The atoms, the ions will dissolve. Dissolution is the metal removal mechanism. So as you can see in this particular diagram also, when you make one anode, another you make cathode. Cathode is a negative electrode, anode is a positive electrode. So the moment you connect it and you make workpiece as positive and tool as negative. Many times this question has been asked. Electrochemical machining mein tool is what? Anode or cathode? Negative electrode or positive electrode? Electrolyte feed is given at high pumping pressure. It is given, and it has some particular function. And electrolyte normally is sodium chloride, and then very small gap is provided and ions will be formed, and because of that dissolution you basically you get the material removal. So material removal is obtained through that particular process. Okay, now answer this question. What is servo function doing in EDM process? What is the role of servo function in EDM process? Can you answer this particular question? What is the role of servo mechanism in EDM process? Okay, so it is to maintain the small constant gap between tool and workpiece. So The servo control is the mechanism which make sure that the gap between tool and workpiece is appropriate. If that gap increases because of the discharge or material removal, then more feed is given to the tool. That is how it is done. So function of servo mechanism in EDM is to maintain a particular small gap between tool and workpiece. So there is a basically servo mechanism which is used auto control between the tool feed and workpiece. That is what the servo control mechanism is. Okay, let's go to next question. Which of the following is incorrect for plasma arc machining? You know, plasma arc machining may you can get good material removal. So which of the following is incorrect? The all other things are correct except one choice. Find out which is incorrect related to plasma arc machining. Temperature generated, power supply, what is the voltage, what is the current, what is the temperature which you obtain in this particular mechanism, particular process, and can electrically conducting material be machined? Can all electroconductive machine materials can be machined? So which one do you think is incorrect? Any guess for that? Okay, answer for that is A is not correct. Temperature is not up to 1000 degrees centigrade. Very high temperature is obtained, 11,000 degrees centigrade. So please remember all other things. In plasma arc machining, very high temperature is obtained, more than 10,000 degrees centigrade. Remember this, more than 10,000 degrees centigrade temperature is obtained. Water cooled nozzle, in which of the non-traditional machining you use water cooled nozzle? That is plasma arc machining. What do you mean by plasma? That is ionized gas. What is plasma? Plasma is the ionized gas. That is what you should know. Plasma is the ionized gas. And another thing you should know is, this other things also you should be knowing. What is the power supply voltage, what is the current, and electrically conducting materials are required. Electrically insulated materials are not used here because yes, you have to create some kind of ionized atmosphere. So these three things are correct. So remember these three things. And also please note down here, what is the plasma, what do you mean by plasma? Plasma gas is different, shielding gas is different. So shielding gas will shield the molten metal part because that will get oxidized. So this is diagram is of plasma arc welding actually. That is by mistake this diagram has come, but it is relevant for this also. Which of the following is incorrect for ultrasonic machining? Which of the following is incorrect for ultrasonic machining? Tool is made of ductile material, very low material removal rate, abrasives are not used, ultrasonic में तो हम use करते हैं. Tool vibrates at very high frequency, that is also true. Tool is made up of ductile material. Ultrasonic machining is used to basically, it is used to machine the hard and brittle material. So which of the following is incorrect? Answer for that is C is incorrect. So in which abrasive slurry is provided and it is oscillating at low amplitude and high frequency. Note down the amplitude also, frequency also. Machining tool is made up of ductile material and tool vibrates at very high frequency to remove the low material removal rate is there. So C, what is C? Abrasives are used. It is written not used, abrasives are used. So note down the tool is made up of ductile material, because if we use the brittle material tool, then obviously because of abrasive slurry, the tool wear rate will be very high. But if we use ductile material, then the abrasive get impinged in the tool. That does not create any wear on the tool. So tool is made up of ductile material, very low material removal rate, abrasives are used, and it vibrates at high frequency. Right? So what will happen is, these are the abrasive particles. Abrasive slurry is applied. These abrasive particles get impinged in the soft tool. Ductile tool के अंदर वो impinge हो जाता है, जिससे tool damage नहीं होता. Tool does not get damaged even if abrasive slurry is impinged into this. So this is what is the tool material used in abrasive jet machining. Okay, now next question is related to electrochemical machining. So you people are watching the lectures of production. This is my third video on production. For your upcoming exam, HPCL and BHEL exam. Okay, now let's go for this. Electrochemical machining. Which of the following is correct? Electrochemical machining, as cutting forces are very high, thin section of workpiece cannot be machined. Okay. Tool material is conductor of electricity. Electrochemical machining, surface finish is bad. Actually, surface finish is not bad. Tool wear is high. Electrochemical machining. Okay, so which one do you think is correct? So B is tool material is conductor of electricity. Other are wrong answers. In electrochemical machining process, workpiece is made anode, tool is made cathode. So two electrodes of workpiece and the workpiece and tool are kept in the electrolyte. Sodium chloride is normally the electrolyte. When voltage is applied across the electrode, material removal starts. Material removal is there. Right? So the surface quality obtained is very good. In the electrochemical machining, surface quality is very good. So let me tell you again and again what is the electrolyte used, that you should know. Sodium chloride. What is anode, what is cathode? So tool is cathode and workpiece is positive electrode, that is anode, that you should know. And pump is used to supply the electrolyte. In the very small gap between workpiece and the tool, electrolyte of sodium chloride is supplied at very high pressure. There are some advantage of supplying the electrolyte at high pressure, so we will discuss about that. Pump for circulating electrolyte, you should know that also. Okay, let's go for next question. Electrochemical machining, which of the following tool is not used? Which of the following tool is not used? Okay, any guess for that? There is one odd one out. Which one is the odd one out? Electrochemical machining. Which one is odd one out? Obviously, this diamond is odd one out. So workpiece is made as anode, tool is made as cathode. Voltage is applied. They are placed very close to each other without touching. Electrochemical machining mein touching is not there between tool and workpiece. And the common tool material are brass, copper, bronze, stainless steel, titanium, tungsten, aluminum, graphite are also used. Tool life is longer compared to EDM and ultrasonic machining. So electrochemical machining mein tool wear is less. Electrochemical machining has less tool wear. So what are the common tool materials used and tool wear rate? Those things you should be aware. Let's go to the next question now. So we have given 4 unconventional machining processes. Most appropriate one to drill a hole of this size. Tell me, which non-traditional machining process shall you use to drill the hole of this size? Which process shall you use to drill the hole of this size? Okay, you have to make a micro drill. Which one shall you use? And the answer for that is electric discharge machining. For die sinking, cavity sinking, blind cavities. Remember these names. The application of electric discharge machining. Whenever you have to make a blind hole, that means not a through hole, blind hole. Die sinking, cavity sinking, blind hole. When you have to make, electric discharge machining is the best. So remember these names and remember that blind hole are produced using this particular mechanism. Electric discharge machining is used to produce the blind holes. So remember this, blind holes are produced using electric discharge machining. So these names are important. I mean, in exam, you can find this die sinking. What is the application? Which non-traditional machining is used for die sinking? So you should know that what are the application. Turbine blade, kaun sa machine use karenge? So those kind of things should be known to you. Application part. Okay, now distance between nozzle tip and work surface increases. Material removal rate becomes what? Abrasive jet machining, ultrasonic machining, water jet machining. So all these are used for hard and brittle material. And distance, that is nozzle tip and workpiece distance, is one of the important criteria. So distance between nozzle tip and work surface increase, what happens to material removal rate? Okay, so answer is C. Abrasive jet machining, for distance between workpiece surface and nozzle tip and flow rate of abrasive. Abrasive flow rate, nozzle tip distance, as you can see clearly. As the nozzle tip distance increases, material removal rate first increases, becomes maximum, and if I increase the nozzle tip distance further, material removal rate will decrease. This is the typical pattern which we get in abrasive jet machining. Similarly, now abrasive flow rate, as I keep on increasing abrasive flow rate, so material removal rate is also similarly related. So why it decreases? Because as I increase the gap now, the velocity will decrease, and hence at particular velocity, particular distance, velocity will be maximum. This is a typical nozzle, at which you supply the abrasive particles to the workpiece. Remember, this graph is very, very important graph. Okay, so can you tell me the temperature in plasma arc machining more than 10,000 degrees centigrade? Electric discharge machining temperature produced by spark between tool and workpiece while machining will be what? So what is the temperature produced by spark between tool and workpiece while machining? What do you think is the temperature? Any guess for that? Keep making the guess. Okay, so you are saying 10,000 degrees centigrade. Okay, so looks like your guess is correct. Electric discharge machining. So there is a spark which is produced, electrothermal non-traditional machining process it is, and the electron and ion undergo the collision and thermal energy is released. Ionized heat flux. So highly ionized region is created. Plasma also is the same thing. So electric discharge machining में spark or plasma is more or less the same thing. Ionized gas is called plasma. Ionized atmosphere, because electron is moving through the molecules and ionized region is created. So that is basically this all about. So 10,000 degrees centigrade is the temperature which we attain here, 10,000 degrees centigrade. Such localized extreme rise in temperature leads to material removal. Right, electrode discharge machining process 10,000 degrees centigrade. So remember these temperatures, these ranges should be known to you. Which of the following is used as dielectric medium in EDM? Dielectric medium in EDM. Dielectric medium कौन सा यूज करते हैं? Dielectric medium. Electric discharge machining. Answer for that is kerosene. Always remember why kerosene is used in electric discharge machining. You should also know why kerosene is used. So in electric discharge machining, use kerosene, though it is inflammable. What is the purpose? To take away the debris. It is circulated at high pressure. What is the pressure at which it is circulated? You see 0.35 Newton per meter square pressure. I think this looks like wrong data. It is not 0.35. This should be megapascal or something per millimeter square. So let me check it. Don't note it. 0.35 pascal is not the pressure. So it is basically circulated. This dielectric is circulated at high pressure. So why kerosene is used? There are some advantages of that. One of the advantages, it does not let the rusting to take place. Okay, so which of the following is not a non-traditional machining process? So we all know turning is not the non-traditional machining process. So all these are non-traditional machining processes which we are aware. Electric discharge, chemical machining, laser beam machining, abrasive jet machining, all these are the non-traditional machining processes. Tool vibrates with very high frequency in which of the following non-traditional machining processes? So tool vibrates with very high frequency in which of the following? So you say ultrasonic machining process में tool vibrates at 20,000 hertz. So it vibrates at 20,000 hertz, and the purpose of the horn is like it is a concentrator to increase the amplitude. That is the purpose of this. Transducer converts the electric energy into mechanical energy. That is a transducer. It is used, and further, this is the purpose of the horn. Okay, which of the following process is reverse of electroplating process? So that also is known to you. Electrochemical machining is opposite of electroplating process. Electrochemical machining and electroplating processes. So in this particular process, we have the tool which is positive, the tool which is negative, cathode, and workpiece which is anode, and pump is there to circulate electrolyte. As I told you, there is a very small gap, and this is what is used. Okay, now wear ratio से भी question आता है, something about wear ratio for tungsten carbide workpiece in electric discharge machining. Right, if a workpiece is made up of tungsten carbide, so what is the typical wear ratio used in EDM, electric discharge machining? What is the typical wear rate which you think of getting? So remember the wear ratio for tungsten carbide work, we are going to get very high wear ratio if I am to break this tungsten carbide, that is 0.5, right? So 0.5 is the wear rate which I can think of getting if this is the tool tungsten carbide. Wear rate will be very high. Wear ratio. So what is the wear ratio is like, what is the wear rate of tool per unit wear rate or material removal rate of workpiece? That is how we define the wear rate. Minimum you get in electrochemical machining. Electrochemical machining mein tool wear is very less, but in other you get the tool wear also. So कितना wear ratio मिलता है, that also you should be aware. EDM stands for electro discharge machining. That is very simple question. Everybody knows that. Electro discharge machining. No need to discuss this question. Everybody knows what is the meaning of that. Okay, material removal rate is given by. Tell me about this formula. Electrochemical machining में. So in electrochemical machining, what is the material removal rate? How do you calculate? Which one is the formula? Okay, so Ajay is saying B, Ajit is saying B, and I think Ajay now is saying A. So what is the material removal rate used? Answer for this is B, IAT over F rho AV, material removal rate. This formula will come. I'll discuss the detailed meaning of each term of this. So current flow and all these things. So electrochemical process का ये formula आएगा भी. Electrochemical equivalent, molecular mass, all these things will come. So remember this material removal rate का एक formula है electrochemical machining का, that is very very important, and उसमें से numerical बनता है. Okay, what is ECG? Electrochemical grinding. Continuous stream of non-corrosive salt solution is passed through workpiece. Solution will act as what? So what do you think with the solution will act as? Electrochemical grinding process में a salt solution is used. What is this salt solution used as? Only coolant, only electrolyte, electrolyte and coolant both. Electrochemical grinding process. You should know what is electrochemical grinding process. So you know what is electrolyte, you know what is coolant. So answer is electrolyte as well as coolant. So electrolyte is used in electrochemical machining, but electrochemical grinding mein it is used as electrolyte also and coolant also. Non-corrosive salt solution, it is used as coolant and electrolyte. लेजर बीम मशीनिंग का भी एक फॉर्मूला है. देयर इज अ फॉर्मूला ऑफ लेजर बीम मशीनिंग आल्सो, दैट इज कटिंग रेट इन मिलीमीटर पर मिनट. एनी आइडिया अबाउट व्हाट इज दैट फॉर्मूला? तो कुछ फॉर्मूलाज हैं इसमें नॉन ट्रेडिशनल मशीनिंग प्रोसेस में. देयर आर सम फॉर्मूलाज व्हिच यू शुड बी अवेयर. इलेक्ट्रोकेमिकल मशीनिंग वाला फॉर्मूला इज वेरी इंपॉर्टेंट, and other than electrochemical machining the other formulas also you should be aware. So cutting rate in millimeter per minute for laser beam machining process. What do you think is the answer for that? Answer is D. So remember this formula. This formula is important. Cutting rate in millimeter per minute laser beam machining. This formula is very important. This will come. So I'll discuss this formula again with you. But remember, this formula is very important in laser beam machining. We are doing the questions of production engineering, expected question for BHEL, HPCL exam, and today's lecture is about non-traditional machining process. It is a non-traditional machining process. Okay, high rate of oscillation of tool in ultrasonic machining is produced by what? DC motor, AC motor, oscillator, or pneumatic generator? What is your answer? What is your answer? How do we get high rate of oscillation of tool in ultrasonic machining? Ultrasonic machining में how do we get the high frequency, high oscillation? So you are saying oscillator. Okay, as the name shows, it is oscillator, right? So control unit is the oscillation, the frequency का range please note down 18 to 40,000 kilohertz. 18,000 to 40,000. Transducer, what is the role of transducer? Converts the current into mechanical vibration. Piezoelectric जो मटेरियल आप यूज कर रहे हैं ट्रांसड्यूसर, उसमें इलेक्ट्रिक एनर्जी इज कन्वर्टेड इनटू मैकेनिकल वाइब्रेशन एंड द हॉर्न और कंसंट्रेटर और ऑसिलेटर उसको बेसिकली जो हॉर्न है वो उसकी एम्पलीट्यूड को इंक्रीज करता है, राइट? इलेक्ट्रिक ऑसिलेटर. Okay, I think this is a different question. This was the question related to another mechanical forming process. Which of the following is not a drying process? Drying process metal forming में हम करेंगे. I think this is a question taken from metal forming. Which of the following is not a drying process? ये बाद में हम करेंगे. Answer is lensing is not a drying process. It is a piercing operation. We will discuss it later on. We will discuss this particular thing later on. As of now, let's talk about only renewable energy, this machining processes, non-traditional machining processes. Okay, so for the same capacity, which of the following process has lowest capital cost, lowest initial investment? Lowest capital cost, initial investment. So कौन सा setup मैं लगाऊं so that initial investment is minimum? Which one is the cheapest to start with? Which of the following non-traditional machining process is cheapest to start with? Electrochemical, abrasive, electrojet machining और chemical machining. इलेक्ट्रॉन बीम मशीनिंग में तुम्हारे पास वैक्यूम रिक्वायर्ड होता है, अब्रेसिव जेट मशीनिंग में पंप रिक्वायर्ड होता है, इलेक्ट्रोकेमिकल में आपको क्या चाहिए? सो अब्रेसिव जेट मशीनिंग, abrasive is cheap, can use sensitive material without damage, initial cost is low. So other processes के comparison में abrasive jet machining. Chemical machining process is also costlier. Why? Because in that also you require the chemical. So chemicals are actually costlier than abrasive materials. That is a, I think, reason this comparison is done. So abrasive jet machining में water is can be used or air can be used. So water and air is cheap. I mean that is a free. Water and air is free. Chemical is costly. Abrasive is also cheap. So he is saying initial investment किसमें आपकी cheap लगेगी? Highest capital cost किसमें चाहिए? सबसे ज्यादा खर्चा किसका आएगा? So which one is costliest to start with? For the same capacity, which of the following process has highest initial investment? Highest capital cost is required in which of the following? Any idea about that? Which one will require the highest? So you are saying laser beam machining. Okay, the answer for this is electrochemical machining process. Electrochemical machining process. Ion dissolution. Electrochemical machining में ना पंप की वजह से ज्यादा, because high pressure pump is there. Electrochemical machining में high pressure pump is used and that increases the cost of this entire system. Electrochemical machining. and then this entire setup, like electrolyte and everything is to be electrode, workpiece is to be made positive, negative. So what are the advantage and disadvantage of electrochemical machining? Initial tooling is costly actually. That is a disadvantage. So electrochemical process ka one of the disadvantages, initial cost is high. Advantages, complex shapes can be machined, delicate part difficult to machine materials, uh, no tool wear. So remember two things only, initial cost is high, no tool, literally no tool wear. Like electric discharge machining mein tool wear is there, ultrasonic machining mein also is there, electrochemical machining mein tool wear is minimum. So where do you get minimum tool wear? You can say electrochemical machining mein we get the minimum tool wear. Reproduction. So reproduction of sharp corner. What is the, which one is having the limitation of reproduction of sharp corners? So you don't get sharp corners. In which of the following you may not get sharp corners, and you need to create the sharp corners. Okay, so reproduction of sharp corner is the limitation of what? So in case of electric discharge machining, let's say, number one, it is used for hard and difficult to machine materials. Non-conductors cannot be used. There is a electrode wear. So further polishing is required in EDM because you get, there is a electric discharge machining mein, because of the electric discharge there are small erosions, small spots. So you get small spots, right? And then you need to make further polishing or grinding operation to get the good surface quality. So you do not get very good surface quality in electric discharge machining. Electrochemical machining and all, you get very good surface quality, but surface produced in EDM, it has a matte type appearance. Matte घर में देखा होगा आपने, वैसा appearance होता है, rough appearance होता है. So further surface finish is required. How do you remove the material in EDM? What is the mechanism? Which mechanism do you use to remove the material in EDM process? Yes, provide the answer for this. So which material, which mechanism? Melting and evaporation. Melting and evaporation is the mechanism. So you should know what is the mechanism in other non-traditional machining processes also. So what is the mechanism used in non-traditional machining processes? You should know the mechanism which you are using in other non-traditional machining processes also. EDM mein it is the melting and evaporation. So EDM process is suited for machining of what? EDM process is suited for the machining of what? It is suited for the machining of what? Conducting, non-conducting, or both? What do you think? Okay, EDM is used for only the conducting. So micro drilling is EDM. Remember this, micro drilling is used through EDM. EDM can be used only for conducting materials. It is used for cutting the conducting materials only, and micro drill can be made using EDM. Harder material can also be machined. So electric discharge machining, surface quality is not very good, but micro drilling is done using this particular mechanism. Okay, let's go for next question. Material removal rate in EDM process, RC, resistance capacitance relaxation circuit, RC relaxation circuit is used in EDM. So in EDM you make use of RC relaxation circuit. Tell me which of the following you will go for, which one of the following is correct in RC circuit of EDM process. So remember that in EDM, whenever I want to release the spark. I want to create the spark. Entire capacitor gets discharged at particular moment and entire energy is released and spark is produced. Then capacitor gets discharged and then again it gets charged and again is discharged. That is called RC circuit. So RC circuit में material removal rate variation, RC relaxation circuit में how that varies. Which one is the answer for that? Okay, material removal rate variation in EDM using RC relaxation circuit, that material removal rate decreases with increase in resistance. So there is a formula between material removal rate and resistance, and that is material removal rate variation decreases with increase in resistance of the circuit. So very, very important information. So if you increase the resistance of the circuit, the variation in material removal rate will be less. Obviously it becomes even more stable as far as the material removal rate is concerned. It becomes more smooth as the resistance is increased in RC circuit. So RC circuit is something which is very, very important for electric discharge machining. So you should know what is the impact of RC circuit on material removal rate variation in EDM. Then you can expect one question from this particular numerical, and this numerical you have done in gate kind of exams also. But in non-traditional machining, if the numerical is asked, it will be asked from this part. So remember this formula and remember that in electrochemical machining, one question on numerical can be asked from electrochemical machining. He will give you material removal, he will tell you that material removal rate is this much centimeter square per minute or something. He will ask you what will be the current required. Atomic weight of material to be removed will be given. For iron 56, valency of iron is 2, density of iron is also given, Coulomb's constant is also given 96500 Coulomb. So he will give you all these values and he will ask you for particular material removal rate what will be the current. So there is a formula between material removal rate and the current. So material removal rate is A is the at this particular mass, this 56 atomic weight of the material. Then Z is the equivalence, that is 2 given in this case. Rho is the density, F is the Coulomb's constant, this 96500, I is the current. So this formula I told you, AI over rho FZ, this formula you should remember in electrochemical machining. Yahan se question can be asked. I'm sure you have noted the question also, and convert it into centimeter cube per second, this, because the rest units are in per second only. So you just remember this formula, and this formula can be asked in the exam, some question about the current from this basic formula. There are only 2-3 formulas in non-traditional machining part. So these 2-3 formulas should be known to you. Okay, go for next question now. What is the wavelength of laser beam? Laser किसको बोलते हैं? Ruby laser, carbon dioxide laser. These are couple of lasers. So what is the wavelength of laser beam? What do you think is the wavelength of the laser beam? Answer for this is 0.4 to 0.6 micrometer. So the wavelength का range ये आप note कर रहे हैं ना, because in the exam direct questions are asked. I have taken these questions from standard book. So direct questions are asked from that particular book, and you should know what is the value. So 0.4 to 0.6 micrometer, and these are some of the things related to laser beam machining. Laser beams are highly coherent, very small dia but parallel. It is a costly method. Laser beam is the most inefficient and costly non-traditional machining. Laser में lot of energy wastage is there. Somebody asks you maximum energy wastage is in which non-traditional machining process? That is in the laser machine. Maximum energy wastage is in that. Micro drills, drilling micro holes, very narrow in the hard materials like diamond. Laser machining is used in making the narrow slots or micro holes in materials like diamond. Wire drawing dies. So this particular method is used for making the wire drawing dies. हीट अफेक्टेड जोन इज वेरी लेस. प्लाज्मा आर्क मशीनिंग में हीट अफेक्टेड जोन इज मैक्सिमम, लेजर बीम मशीनिंग में हीट अफेक्टेड जोन इज मिनिमम. So these things also you should be aware. Where do you get maximum heat affected zone and where do you get minimum heat affected zone? What is the difference between laser beam machining and electron beam machining? Laser beam machining and electron beam machining. Where do you use the reflecting mirror in the laser beam machining? Where do you use the capacitor in electric discharge machining and laser beam machining? Why? Because you want sudden flow of energy, and capacitor is the device which gives you sudden discharge of energy. Ruby crystal is used in the laser beam machining, and then lenses are used in laser beam machining to concentrate it further. Electron beam machining में you need vacuum, you need magnetic lens, you need deflection coils, and you can get very different shape, curvilinear shapes, contours. You can get the contours in electron beam machining. So you should know what is the supply voltage and all, how this is required. Electron gun is used here, ruby laser is used there. And this slide you will, I'm sure, stop it later on and you will note down the important points between laser beam machining and electron beam machining. Always vacuum, electron beam machining. Laser beam does not require vacuum. Electron beam machining, electrically conductive workpiece only. Laser beam machining, workpiece can be conductive or non-conductive, anything. No X-ray is produced in laser beam machining. X-ray is generated in electron beam machining. Okay, let's go for next question. Maximum material removal rate of EDM process is how much? Okay, so what is the maximum material removal rate of EDM process? Answer for this is A, but please stop this slide and note down the material removal rate in different. Very, very important slide, very important information. Material removal rate is calculated in millimeter cube per second. So specific power requirement, accuracy in micrometer, surface finish micrometer, and material removal rate and comparison of the non-traditional machinings. Very important slide. Please stop this slide later on and note down these things. Ultrasonic machining में material removal rate, you see where it is. Plasma arc machining very high, electric discharge machining very high compared to others. Maximum material removal rate is plasma arc machining. Plasma arc machining is very, very rough operation. Specific power requirement is maximum in laser beam machining. Most inefficient machining process is laser beam machining. Most inefficient is laser beam machining process. So as I told you, you will stop this slide later on and note down all these informations which I provided you. You should note down these things. Which of the following is true related to laser beam machining? Laser beam machining, which of the following is true? Which of the following are properties? Please go through this. Low initial cost, not very efficient process, that is true. Heat affected zone का presence नहीं होता, 3 is not there. So remove 3 and only 2 choices are left. I think A and E. Heat affected zone नहीं होता उसमें, यह बहुत ही कम होता है उसमें. Micro holes cannot be drilled, not suitable for heat sensitive materials. Yes. What do you think is the answer for that? Go for it and tell me what is answer for that. Answer given is C. That means 2, 3, 5. Okay, 2 is not efficient. That is okay. 3, presence of heat effector zone, but very less, maybe. 5, not suitable for heat sensitive materials. Micro holes can be drilled. Initial cost is more. That is true. So I think heat effector zone is there, but very, very small. That is the reason he's made it correct. Okay, then what is laser beam machining limitations? High initial capital cost. Initial investment required is high because of all this setup. Maintenance cost is also there. It is not very efficient process. As I told you, lot of energy is dissipated. Very less energy you get, but lot of energy is dissipated. Presence of heat effector zone in gas assisted, okay, carbon dioxide laser cutting. एल्यूमिनियम के लिए सुटेबल नहीं है, not suitable for heat sensitive material. Micro holes can be drilled in difficult to machine materials. So these are some of the advantages or benefits of laser beam machining and some limitations of laser beam machining. Let's go for next question. Electron beam machining ka. This question is related to electron beam machining. Chemical etching by high energy electron, mechanical erosion due to impact of high energy electron, sputtering due to high energy electron, melting vaporization due to thermal effect impingement. Melting and vaporization to hota hai. Melting and vaporization is there. Which of the following is true? Mechanical erosion तो नहीं होता. Vibration and melting and vaporization looks like okay. Melting and vaporization can be there. Okay, so what do you think is the answer? D. D means only 4. Yes, D is the only 4. So electron gun is used in electron beam machining. There is a deflection coil, there is a magnetic lens. So those things are there, and vacuum is created in laser, this electron beam machining. Type of energy used in electric discharge wire cutting. Type of energy which is used in electric discharge wire cutting. Wire cut EDM. वायर कट ईडीएम में कौन सा एनर्जी यूज होता है? दिस इज वेरी सिंपल, सिंपल क्वेश्चन फॉर यू. दैट इज इलेक्ट्रिक एनर्जी एंड थर्मल एनर्जी. वायर कट ईडीएम में इलेक्ट्रिक एनर्जी एंड थर्मल एनर्जी. इलेक्ट्रिक डिस्चार्ज इज देयर, दैट इज ट्रू, and that is also part of thermal energy. Thermal energy, that means heat energy released. I gave you this classification. Please go through this classification also for micro machinings. Micro machining, why they are called is because the material removal rate is not very high. Like traditional machining process, jaisa material removal rate is not there. Hence, you can use this for micro machining. So electric energy, thermal energy. Electrical अलग से यहाँ पे शो नहीं किया है, but the mode of getting thermal energy is through electric energy only. Do you know what is ablation process? What is ablation mechanism? What do you think is the ablation mechanism? Which process you use ablation mechanism? What do you mean by ablation? Laser beam machining. Okay, looks like okay. This is ablation. So what is ablation is this? It is also called laser blasting. Removal of the material from solid surface by irradiating it with laser beam. That is called ablation. So laser ablation या laser blasting means this. Laser ablation or laser blasting means this. What is ablation is energy threshold is reached which causes the damage and material removal. When the energy threshold is achieved, that is the ablation process. that is ablation process. Go through this. That is observed in laser machine. Which of the following laser source gives you highest power density? In which of the following you get the highest power density? Power per unit area. Power density means power per unit area. Which of the following laser source gives you highest power density? Okay, you see plasma, area has to be minimum. Laser pulsed gives you highest power density. What do you mean by power density? Power in watt to cross section area in centimeter square or millimeter square. So watt per millimeter square or watt per centimeter square. Laser beam, this is how it is. So very less area, laser supplied on very less area, that gives you very high power density. Okay, can you answer this question? In ultrasonic waves, frequency for non-destructive testing of material are in the range of what? Can you tell me the range of the frequency? Ultrasonic waves, NDT, non-destructive testing. Let me give you the answer for this. 15 megahertz, 0.5 to 15 megahertz. But this is a non-destructive testing question, not non-destructive testing, not non-traditional machining. So as of now, let's talk about non-traditional machining only. This same question we did. Molecular mass is given, Coulomb's constant is given, and we have also seen material removal rate, and equivalence is also given, and current is to be calculated. Same question. I told you that a question in electrochemical machining can come from here. So material removal rate is given to us. Material removal rate is given to us. We know the formula. Material removal rate formula is this: AI over ZF. Z is 2, A is given as molecular mass 55.84. So Z is given. Current we need to find. Material removal rate is given. How do you find material removal rate? Material removal is 70 gram. In how much time? That also is given. So in gram per second we can calculate material removal rate. So if material removal rate is known to us, other informations are given to us. So in non-traditional machining, if numerical is asked, it will be asked only from one particular part. This is the part from where you can expect the question. Right, now let's go forward. Material removal rate will be higher in ultrasonic machining process for materials which have what? High ductility. He's talking about ultrasonic machining. He's talking about ultrasonic machining process. Material removal rate will be higher in ultrasonic machining processes for material with what? High ductility, high fracture strain, higher toughness, lower toughness. What do you think will be the answer? Okay, so material which have high brittleness, they are low in toughness. You know, if toughness is more, that means the material has the capacity to take the impact load. If toughness is less, that means it cannot take the impact load. It will break, it will fracture. So ultrasonic machining में material removal rate is more if fracture probability is more. More the toughness, less will be the fracture. Less is toughness, more will be fracture. That is the reason answer for this is low toughness. Low toughness. Material removal rate will be higher for those materials which are brittle in nature or which are lower in toughness. Electro discharge machining workpiece is connected to what? In electro discharge machining, the workpiece is connected to what? Cathode, anode, earth, or electrolyte? What do you think? These are the typical questions which you may get. So remember this. Tool is connected to cathode, tool is negative, and workpiece is connected to positive, which is anode. Cathode is negative, anode is positive. So tool is connected to negative, cathode, and workpiece is connected to positive, which is anode. Remember this. So tool and workpiece, which one is anode, which one is cathode? That question is normally asked. Right? Let's go for next question. Abrasive grains are used in which of the following processes? Electrochemical grinding, ultrasonic machining, laser beam machining, electric discharge machining. Action of abrasive grains. In which of the following abrasives are used? Answer is B. इलेक्ट्रोकेमिकल ग्राइंडिंग में एब्रेसिव यूज नहीं होता, वो इलेक्ट्रोकेमिकल प्रोसेस है. ग्राइंडिंग मींस फिनिशिंग इज आल्सो डन. While machining copper alloys by electrochemical machining, the electrolyte used is, which one is used as electrolyte in electrochemical machining? Electrochemical machining, electrolyte used is what? Sodium sulfate. Okay, he's given you answer sodium sulfate. Sodium chloride is not saying, sodium chlorate is writing. Electrochemical machining, sodium sulfate is used. Sodium chloride होता तो ले लेते, but I don't know sodium chlorate. Sodium chlorate is not sodium chloride. Okay, this tool and workpiece, there are some hydrogen bubbles formed. Please note this also. Hydrogen bubble is the main trouble in electrochemical machining. Hydrogen bubble is the main trouble in electrochemical machining. Electrode is anode, workpiece is cathode. This tool is cathode, sorry, and workpiece is anode. And also remember hydrogen bubbles. Hydrogen bubble is also trouble. Yes. So Tarun, sodium chloride is used. I need to check what is sodium chlorate. This we have done. Electrochemical machining, material removal rate. In which of the following material removal rate is maximum? That question has been asked many times. Unconventional machining process में sequence क्या है? Material removal rate का sequence. Okay, electrochemical machining, इलेक्ट्रिक डिस्चार्ज मशीनिंग, अल्ट्रासोनिक मशीनिंग. अगर प्लाज्मा आर्क मशीनिंग आएगा तो मैक्सिमम है. प्लाज्मा आर्क इज द मैक्सिमम, बट ही विल नॉट गिव यू प्लाज्मा आर्क बिकॉज he will give you 2-3 which you can easily, which are having more or less similar kind of material removal rate. Material removal rate with respect to grain size. Yes. In ultrasonic machining, material removal rate with respect to grain size increase in what? As the grain size increases, what happens to material removal rate? Decrease and then increase, increase and then decrease. So what is the answer? So you are saying increasing and then decreasing. So grain size may it increases and then decreases. So there are different parameters: amplitude, frequency, grain size. There are different parameters and its impact on material removal rate. Different parameters and the impact on material removal rate. Right? So remember this. Answer is increase and then decrease. Yeah. Answer this question very simple. Machining process in which metal of a workpiece dissolved. Machining process in which metal of a workpiece is dissolved. Answer is electrochemical machining. Electrochemical machining. Opposite of electroplating. So dissolution I have discussed. Dissolution is the mechanism. Please answer this question. If I don't change any other parameter, then tool wear in electric discharge machining and how that is related. Tool wear in electric discharge machining would be less. How the tool wear is related to the tool material. Tool material means thermal conductivity and specific heat. How the tool wear rate is related to the tool material, conductivity and specific heat. How that is related? A, B, C, D. Okay, the answer is this: high thermal conductivity and high specific heat. High thermal conductivity and high specific heat. If the thermal conductivity of the tool material is more, then heat will not be concentrated in the tool and hence tool wear will be less. And same is the specific heat. If conductivity and specific heat of the tool is good, then the heat will not be concentrated and the tool wear will be less. That is the logic. A is the answer for that. Please remember something about tool wear, electrode wear. I want you to remember something about graphite electrode. Wear ratio in graphite electrode is very high. Workpiece to electrode, I mean 3-part workpiece, 1-part electrode. That is the meaning of wear ratio. Workpiece to electrode 3:1. Normally metallic tool. But graphite may this is 10:1. Very high wear ratio in graphite electrode. Graphite electrode are used and tools is subjected to erosion and wear. The tool is subjected to erosion and wear. So metallic में 3:1, graphite में 10:1. Why do you use dielectric? Why do you use dielectric in electric discharge machining? Why are you using the dielectric? All of these: coolant to control the spark discharge, movement of spark. So answer is all of these. So what is the role of dielectric? Kerosene is used as a dielectric. So normally kerosene is used as dielectric. And why are you using the dielectric in electric discharge machining? So it helps in movement of spark discharge, acts as coolant. Next question. Electrochemical machining, the gap between tool and workpiece. Now gap is also important parameter. So in electrochemical machining, what is the gap between tool and the workpiece? Yes, any guess? And remember these values also. You never know what question is going to ask you. Gap between tool and workpiece in electrochemical machining. Gap between tool and workpiece in electrochemical machining. It is reversal of electroplating. Electrolyte is used as current carrier. The gap washes the metallic ion away from workpiece. High pump electrolyte is supplied. High pressure electrolyte is pumped. Tool is used as cathode. Tool is made up of brass, copper, bronze, stainless steel. Current maintained is between 5 ampere to 40,000 ampere depending upon the machining. The gap is given is 0.75 millimeter. So remember what is a gap and all. Remember these values. I mean, in GATE kind of exams, it will never be asked, but in this your public sector exams, these questions are normally asked. Which of the following process in non-traditional machining you use the soft material tool to cut the hard workpiece? Soft material tool to cut the hard workpiece. Which of the following is used? Turning may you use the hard tool to cut the soft material. In the turning, the plastic deformation process takes place. Tool should be harder. But in non-traditional machining, grinding is also hard tool is required, abrasive is required. Electric discharge machining, okay. So what is the answer for this is electric discharge machining. Not honing. Honing is also kind of surface grinding process. Honing is also super finishing process. Electro discharge machining. Soft tool, hard material. Okay, can ductile materials be machined using ultrasonic process? Ultrasonic machining process? Answers you see carefully. Can I use ultrasonic machining? Can I use ultrasonic machining to machine the ductile materials? That is the question. False. Ductile material can be machined using ultrasonic machining. True or false? So true process, true answer or wrong? Okay, so answer is false. Ultrasonic machining is used to machine hard and brittle material, something like glass, carbide, ceramic, hardened steel. And these materials are not conductive. The material of the tool is soft, and if the tool material used is hard, the tool wear will be very, very high. So we use the soft material as tool for its, less wear rate. Non-conductive materials can be machined by. Non-conductive materials can be machined by. Non-conductive materials can be machined by which of the following? Laser beam, electric discharge, electrochemical, or all of these? Yes, what is the answer? So you are saying only laser beam machining. Yes, laser में impact नहीं होता. So in the laser does not matter whether it is conductive or non-conductive, but electric discharge machining, electrochemical machining में it has to be conductive material. Electrolyte is used in which of the following process? Electrolyte is used in electrochemical machining, and normally we use sodium chloride. Sodium chloride is used as the electrolyte in electrochemical machining process. Okay, in electric discharge machining, how do you separate the tool from workpiece? So how do you separate the tool from workpiece in electric discharge machining? What do you think? In electric discharge machining, how do you separate the tool from workpiece? Yes, that is the dielectric used there. Why do you use dielectric? So you will stop the slide here and you will note down the things from here. It is the insulator between tool and workpiece till particular voltage is reached. As I told you, in the electric discharge machining, you have something which is called your capacitor, which discharges the energy. So it initiates the spark between electrode and workpiece, flush away the metallic particles to prevent the short circuiting. It is used as coolant. Only electrically conducting materials are machined using this process. EDM is best suited for making intricate cavities and contours, which otherwise are difficult to produce with conventional machining cutting. There are series of electric discharge. There are series of electric discharge, and there is a reason we do not get very good surface quality in EDM, because spark gets discharged, capacitor gets discharged, spark is produced, and then again it charges. So you get series of the sparks. And you need to use the servo controlled mechanism in this. That is also required to maintain particular gap. To maintain particular gap, servo controlled mechanism is used. That is to be used. So important slide है, इसको note करेंगे आप बाद में. This is important slide for you. So selection of non-traditional machining process for a particular application depends upon what? Selection of non-traditional machining process for a particular application depends upon what? Shape to be machined, process capability, physical parameter of process, or what? Or all of these? What do you think? Okay, so you want to go for all of these. So answer is all the parameters. So which machining, non-traditional machining, which non-traditional machining process you want to use, that depends upon many parameters. That depends upon many parameters. Physical parameter, shape to be machined, process capabilities, etc. Electrode discharge machining, better surface finish is obtained at. In electrode discharge machining, better surface finish is obtained at what? Better surface finish is obtained at. Can you answer this question? In EDM process, if you want to get good surface quality, you need to, how do you need to change the current and the frequency? Good surface quality if you want to make, how should you change the surface, how should you change the frequency of discharge and the current of discharge? Okay, the answer is C. There's a formula between frequency and current. So surface roughness is surface quality is directly proportional to sparking time and charging time. There's a formula for that. There are microscopic craters produced in the electric discharge machining. Note down, this is an important point. Microscopic crater. Crater means small, cavity. Crater means small cavity. If the energy produced per unit pulse is high, then the crater will be also of high depth and lead to low surface quality. So you should not supply more energy per pulse. So if the frequency is high but discharge is less, then you get good quality. Understand this. In electric discharge machining, you get the discharge and the material is removed through some kind of vaporization process, electric discharge mein, and crater is formed, cavity is formed. If the current supplied is more, then the depth of the crater will be more, quality will be less. So supply less current, but the frequency of discharge you increase. So if you increase the frequency of discharge, more craters of very small depth will be formed. That means good quality. Less crater of large depth lead to poor quality surface. More crater at high frequency but small depth because of low current will give you good surface quality. That is the meaning of it. So EDM process में electric discharge machining में, this is how you need to understand the entire thing. No tool wear. Which of the following process में tool wear is not there? Which of the following non-conventional machining method leads to low tool wear? In which of the following tool wear is less? Electrochemical machining में tool wear is not there. In the electrochemical machining, tool wear is not there. Electrochemical machining में tool wear is not there. Right? Electrochemical machining, gap maintained. I think the similar question we have done. Electrochemical machining, the gap maintained tool and workpiece is of the order. ये gap वाला एक you please clear it properly and note this electrochemical machining में gap वाला question. 0.5 millimeter approximately that gap. We have done earlier also this question. So what should be the gap between tool and workpiece? So what should be the typical gap between tool and workpiece? Note down this, and this is an important point. For which of the following cases will you use the, yes, so it was in previous question 0.75 millimeter was given. Now it is given that we don't have 0.75 millimeter. So that is what I'm telling you. Please clear this once. In the previous question also you see what was the gap given there. Ultrasonic machining is best suited for which of the following? Why diamond? Drilling, grinding, profiling, coining, threading, welding. And it is used with abrasive hard materials. And the workpiece is also hard. Glass, ceramic, diamond, quartz, semiconductor, they all are in the same category. They all are in the same category. So ultrasonic machining, if you see the choice of material is given, all other are soft materials. Diamond is the hard material. Okay, so erosion caused by rapidly recurring spark discharges. We know that electric discharge machining. So remember that in electric discharge machining, the mechanism of material removal is erosion. Mechanism of material removal is erosion. Erosion is used to remove the material in electric discharge machining. Maximum metal and have minimum wear on tool. What should be done in electric discharge machining? A, B, C, D. Hit the right answer. So tool should be made cathode, workpiece anode, tool anode, workpiece cathode. What of the things? So you want maximum material removal rate, but minimum wear on tool in electric discharge machining. That is the reason tool is made negative and workpiece is made cathode. Spark frequency is given. Material removal rate ka value is also given. Forced circulation. This term is very important. Forced circulation of dielectric. Natural circulation nahi. Forced circulation through pump. Kerosene. Tool is made of brass and copper. And to protect the tool from wearing, tool is made negative. If tool is made negative, the electrons are going to impinge on workpiece. Tool is negative, electron will impinge from tool to workpiece. So tool wear will be reduced that way. So lot of information in this paragraph. Remember this information, write somewhere, copy this information, and question can be asked from this part. So forced circulation of dielectric. Which non-traditional machining use dielectric and forced circulation? In the ultrasonic machining, metal removal is achieved by what? In the ultrasonic machining, how do you attain the metal removal? Ultrasonic machining. Okay. Is it hammering action of abrasive particles? Ultrasonic waves. Ultrasonic has a particular frequency. Ultrasonic means we can't detect it. Hard to machine materials, brittle materials mein, I can make the circular or non-circular hole. It can be circular hole, it can be non-circular hole. How do you create the ultrasonic waves? Through piezoelectric or magnetostrictive effect. Piezoelectric material, magnetostrictive. Magnetostrictive principle is there. Like if you supply the current, then there is going to be deflection. And that deflection eventually is converted into mechanical vibration. So electric energy into mechanical vibration through piezoelectric materials. Piezoelectric materials are those through which if you supply the current, then these materials undergo deflection, and that deflection is converted into vibration. Tool and work are not in contact in electric discharge machining. Tool and workpiece are not in contact with in electric discharge machining. Does that mean tool wear is not there? Does that mean no relative motion? There is a relative motion. Tool keeps on coming down. Tool wear is there. Power is consumed. No force between tool and work occurs. That is true. Answer for this is D. Tool wear is there in electric discharge machining. Which of the following processes does not cause tool wear? Ultrasonic, laser beam, electric discharge? Yes, what you will answer? Does not cause tool wear. Which of the following process does not cause tool wear? Laser beam machining में tool wear नहीं होता. In the laser beam machining, there is no tool wear. There is a coherent light beam which is impinging on a small spot. Melt it and vaporize it. ये नोट कर लेना. Carbon dioxide, nitrogen and helium in ratio 1:1:10. Pressure 20 to 50 millimeter of mercury. Ruby laser is also there. Carbon dioxide laser is also there. Which of the following process has very high material removal rate efficiency? Very high material removal rate efficiency. Yes. Material removal rate is very high. Rate efficiency. See, he is not talking about material removal rate. He is talking about material removal rate efficiency. That means he is giving you output is material removal rate is the output. Input is how much energy you are consuming to remove that particular material. That parameter you have to consider. So electric discharge machining mein, that particular thing is very, because it is controlled. You are using the capacitor, it is charging, and then the moment it is discharging, material is removed. Continuous energy is not being supplied. Electrochemical machining mein continuous energy is supplied. Energy requirement is more there. Material removal rate no doubt is more. But electrochemical machining and electric discharge machining में ज़्यादा efficient is electric discharge machining, not electrochemical machining. उसमें continuous supply of energy is there. So don't get confused. Consider the following workpiece material: carbide, glass, copper, ceramic. Ultrasonic machining में which one shall you use? Ultrasonic machining में don't use hard material. Ultrasonic machining, workpiece, not tool. Tool should be soft and workpiece should be hard. So workpiece cannot be copper. Copper can be tool. So 1, 2, 4, carbide, glass, ceramic. Yes, copper cannot be. So C is the answer. Ultrasonic machining is used for making dies, dental applications, hard carbide, glass, precious stones. There you can use these materials. So 20 to 30 hertz is the frequency we use it. Slurry of the abrasive grain is used in this. How the material removal mechanism is there in electrochemical machining mein? What is the material removal mechanism you people are using? Metal in electrochemical machining process is removed by what? Electrochemical machining process. Okay, what is the answer? Dissolution actually. डिसॉल्व होना, माइग्रेशन ऑफ आयंस, आयंस का डिसॉल्व होना. सो डिसोल्यूशन, डिसॉल्विंग द आयरन आयंस. मेटल इन इलेक्ट्रोकेमिकल मशीनिंग cannot be chemical etching. Migration of ions towards tool, that is called dissolution also. Electrochemical machining में material removal is due to what? Ion displacement, that is what we are talking about. It is the ion displacement. Remember this thing, dissolution. It is also dissolution or ion displacement. Dissolution or ion displacement is same. Which of the following is not a limitation of electrochemical machining process? Not a limitation. Very expensive. Sharp corners are difficult to produce. Surface finish is not good. Surface finish is good. Okay. Surface finish is good. It is very expensive, that is true. Sharp corners are difficult to produce electrochemical machining because material removal is ion displacement. Corrosive media, electrolyte is used. Work material removal in ultrasonic machining is proportional to what? Rate of work material removal in ultrasonic machining operation is proportional to what? Rate of work material removal in ultrasonic machining operation is proportional to what? So what answer would you like to give? Volume of material, work material removal per impact, number of particles making impact per cycle, frequency of vibration. Yes. Don't blindly put D. You put D only if you are sure that all the things are correct. Don't blindly put D. So you will stop this slide later on and you will note down this, all the parameters. Rate of work material removal in ultrasonic machining is proportional to volume of material removal per impact, number of particle making impact, yes, frequency of vibration. So this is proportional to all these three factors. Okay, turbine blade. Machining of turbine blades. Turbine are very hard, strong materials. Turbine blade is made up of strong materials. So which is the suitable manufacturing process for machining the turbine blade? Would you like to answer? Turbine blade. Would you like to answer this? Electrochemical machining. Electrochemical machining में the hardness of the workpiece is not a criteria. Hardness of the workpiece is not the criteria. Most suitable manufacturing process for machining the turbine blade made up of this special alloy is electrochemical machining. Electrolyte which is used in electrochemical machining process is, I think, aqueous solution of common salt. aqueous solution of common salt. That is sodium chloride. So we are talking about sodium chloride here, NaCl. Which of the following is the most important parameter of EDM? Most important parameter of EDM. Yes. Would you like to guess? Electric discharge machining, thermal capacity, strength, hardness, geometry. Guess. Which of the following is the most important parameter of EDM? It has to be thermal capacity only. Yes, it is thermal capacity. Electric discharge machining में the electric energy is discharged in one go, and that is the reason the thermal capacity is most important parameter in EDM. Thermal capacity is the most important parameter in EDM. Okay, hole of 1 millimeter is to be drilled in glass. Can you choose the process? Hole of 1 millimeter is to be drilled in the glass. How do you want to do it? Laser, plasma, ultrasonic, electron beam drilling. Okay, ultrasonic drilling. Ultrasonic drilling is the best for micro drilling process. Slurry is provided, and piezoelectric transducer is there, horn is there. You should know what is the meaning of all this. What is the meaning of horn, and what is the where you supply the pump. Which of the following is not true of electrochemical machining? Which of the following is not true for electrochemical machining? It can machine highly complicated shapes in a single pass. Tool life is very high. Machinability of workpiece is independent of properties. Kerosene is used as electrolyte. So which one do you think is not correct? Not true for electrochemical machining. Which one do you think is not true? Electrochemical machining में you don't use kerosene, you use the electrolyte. So I think that was sodium chloride, sodium chloride, sodium sulfate, sodium nitrate. These kind of things we are using. Why do we use the electrolyte? To complete the electric circuit, to carry away the heat and product produced at the machining zone. It should have high thermal conductivity, high chemical conductivity, low viscosity, high specific heat, high chemical stability. These are important points. So you will stop the slide later on and you will note down the things. They are important things. You will stop the slides later on and then you will go through all this. Done? Now, which of the following is a false statement? लास्ट में एक बार और क्लियर कर दीजिए कि किसमें इलेक्ट्रोलाइट यूज होता है, कौन कौन सा. सी electrolyte, I told you there are some names. Most common is sodium chloride, then sodium nitrate, sodium sulfate. Sodium chlorate करके कुछ नहीं होता, जो which I understand. Sodium chloride is the most common, but other than most common there are other electrolytes also. Sodium nitrate, sodium sulfate, they can also be used. तो ये दो तीन नाम हैं जो आपको याद रखने हैं. नॉर्मली सोडियम क्लोराइड से क्वेश्चन आएगा. Which of the false statement about electro discharge machining, EDM? In the electric discharge machining, section to be machined thick नहीं होता, because ये micro machining processes हैं. All these non-traditional machining processes are micro machining processes. That means we are not removing the material as high as we do in the traditional machining. So micro machining है तो thick material we don't cut. So section जो होता है that is not very thick. Electro discharge machining can cut hard material. Surface finish. Electric discharge machining, when it is comparing, maybe comparing with the normal machining processes, very good surface finish you don't get in electric discharge when you compare with electrochemical machining. Electric discharge mein surface quality obtained is not very good, but when you compare it with the traditional machining you may get better. Material removal rate is less than electrochemical, obviously. So most incorrect in this is C. Most incorrect is C. You will say, sir, you have told that electric discharge machining mein quality, surface quality is not very good because crater are produced. But you see, with what you are comparing? Are you comparing EDM with ECM or other non-traditional machining? Then what you are saying is true. But if you are comparing it with the turning operation, then you get better surface quality. So most incorrect among all is section to be thick. Okay, Faraday's law. All of you know that. Process in which material removal rate is governed by Faraday's law. I told you in electrochemical machining may we use Faraday's law also, right? Yeah, so you know that. Electrochemical machining. EDM में material removal rate is proportional to what? In the EDM, material removal rate is proportional to what? Frequency, energy delivered per spark, both or none of these. Okay. So it is dependent on both A and B. Frequency of charging, energy delivered each spark. Material removal rate will be proportional to how much energy you supply. If you supply in each spark, you give more energy in the form of high current. Obviously, material removal rate will be more, and frequency of charging, if it is more, you are giving more energy. So both these A and B are giving more energy, and hence more material removal rate. Which of the following is most important of EDM? That we have done, right? ये हम सेम कर चुके, thermal capacity. Tool material in ultrasonic machining. Which of the following is the tool material used in ultrasonic machining? Ultrasonic machining में tool material used is not very hard. Out of these four, mild steel is the ductile or soft material. Others are very hard materials. So mild steel can be used as tool in ultrasonic machining. Mild steel can be used. Current used during EDM. Which current do you use during EDM? AC, DC, pulsed AC, pulsed DC. Very important question. Pulsed AC, pulsed DC. In pulses you supply EDM. Remember pulsed DC. Road memorize कर लो इसको. Pulsed DC is provided in EDM process. Pulse means in particular pulses because it will charge and then discharge, charge and then discharge. So DC current. Pulsed DC. Efficient cutting of the material with laser beam machining, material should be what? For efficient cutting in laser beam machining, the material should be what? What kind of material are you looking for? Good conductor of electricity, bad conductor of heat, good conductor of heat, good conductor of heat and electricity. What do you think? For efficient cutting through laser beam machining, if the workpiece is good conductor of heat, it will take out the heat energy. What do you think is the answer for this? Good conductor of heat, bad conductor of heat. I tell you why. Answer is bad conductor of heat. Laser is thrown on a workpiece. If the workpiece is good conductor of heat, heat will be dissipated. Localized melting will not be there. If the workpiece is good conductor of heat, the workpiece will dissipate the heat in entire its body, and localized melting cannot be there. Now think of if the material workpiece is bad conductor of heat, when the laser is thrown on that, localized very narrow zone may melting will be there. Hence workpiece should be bad conductor of heat. It should be bad conductor of heat. Remember this. Which has minimum power consumption in kilowatt per centimeter square per minute? Least power consumption. Plasma, laser, ultrasonic, electric discharge machining. It is looking like difficult to believe, but yes, plasma arc machining में power consumption is minimum. Per unit area, plasma में wide is less per centimeter square. Plasma arc machining में the surface area involved is very large. In others, surface area involved is very less. Think of laser beam machining and this electron beam machining. Electron beam, laser beam में centimeter square area is very less. Plasma में it is very high. That is the reason this is less. Okay, so I think we have come to an end of this class now. We have completed all the questions. ये वीडियो को सुन लेना if you have not listened to this thoroughly. This is my third video on production engineering. First was casting, second was welding, third is this. And I'm also going to give you some more, right? So keep revising. There is a high probability. Slides में बहुत information है. The slides which I have given you, lot of information is there. Don't miss the information. Prepare well, because there is a cutthroat competition nowadays, and you want to score high to go in the interview further. You need to score really high. So don't miss it. Listen to this entire video again and again, and I'm very sure questions will pop up from here. I will keep on taking questions on production engineering and industrial engineering. So chalo, I'll meet you in the next class, and thanks a lot for being here and attending the class. Thank you. See you in the next class.